Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon, everyone. Distinguished guests, ladies and gentlemen. On behalf of the organizer, it's my pleasure to welcome all of you to the second Kyushu University Forum, KYUDAI Now Malaysia 2025. Thanks to UTM for great hospitality. This special program is proudly hosted by Kyushu University, Institute for Asian and Ocean Studies, with the strong collaboration with Malaysian Kyushu University Alumni Association, my KYUDAI, and in collaboration with the Campus Asia Plus EEST. My name is Dr. Nik Muhammad Izwar bin Nik Ibrahim. I am the Secretary, Malaysian Kyushu University Alumni Associations, and also serving as the Senior Lecturer at the RB High University of Automotive Malaysia. I am truly honored for me to serve as your MC of the ceremony today. We are deeply grateful to all of you for joining us this afternoon despite your busy schedules. This program we divided into sessions. Session 1 from 1:30 until 5:30 p.m. we will have the symposium featuring research presentations and discussion that highlighted the innovative and collaborative work of Kyushu University and Malaysia University. The second sessions from 6:30 to 8:30 p.m. we will have the buffet-style dinner gathering at Pulau Seperti Resort for chance a network, exchange idea, and strengthen the bond of friendship and collaboration between Kyushu University and Malaysia partners. To officially begin this afternoon sessions, it's my great honor to invite Professor Dr. Akira Harata, Deputy Director General of Kyushu University, Institute for Asian and Ocean Studies, to deliver his welcome remarks. Prof. Harata, the floor is yours.
Good afternoon. Can you hear? Yeah, welcome to Kyushu University Forum, KYUDAI Now, in collaboration with Campus Asia Plus East Summer School, and supported by my KYUDAI, Malaysia Kyushu University Alumni Association. I am Akira Harata, the Deputy Director General of Q-AOS, Kyushu University Institute for Asian and Oceanian Studies, and Executive Assistant to the President of Kyushu University, in charge of lifelong education for graduate students and researchers throughout Kyushu University. At the same time, I'm a professor of ICSES, Interdisciplinary Graduate School of Engineering Science, Kyushu University, and have been involved in the Campus Asia Plus East Summer School of International Cooperation Education Project based on WZE since its inception in 2011. We are pleased to announce that Q-AOS and Campus Asia Plus East Summer School have jointly organized a collaboration event for KYUDAI Now in Malaysia, which we are able to hold today in this format. We'd like to express our sincere gratitude to everyone who made this event possible, as well as to those who contributed to its realization. And thanks a lot for taking time to be here, to join KYUDAI now. It is our great pleasure to have this opportunity for talking about ongoing and future collaboration between Malaysia, China, Korea, and Japan. We'd like to express our sincere gratitude to UTM, University of Technology Malaysia, and Campus Asia, also Kyushu University, for their tremendous effort in arranging the venue and coordinate the schedule. We also extend our heartfelt thanks to the faculty members of SJTU and PNU, Shanghai Jiangsu University and Busan National University, for approving the holding of KYUDAI now and recurrent education events. We'd also like to express our sincere gratitude to all alumni. Our alumni who helped make this event possible. KYUDAI now has several objectives to introduce cutting-edge research from active researchers, to build new collaboration, and to renew old friendships. This time, KYUDAI Now event is the first joint project between Q-AOS and Graduate Schools Education Program, Campus Asia. We hope that this event will bring beneficial results for everyone involved. This afternoon, cutting-edge scientific presentation will be given. Tomorrow afternoon, lectures will be held to deepen your understanding of today's cutting-edge research. Lecturers will be available for consultation in the VK1, another room, waiting room outside of lecture hours. We encourage all researchers to take advantage to this opportunity and to visit us. Questions from Campus Asia students are also welcome. Tonight's reception can be used as well. Finally, I'd like to express my sincere gratitude once again to the faculty members of UTM, SJTU, and PNU, as well as to all Campus Asia students and all those in attendance. I hope that this event will be meaningful for everyone and serve as a catalyst for new collaborations. With that, I'd like to conclude my welcoming remarks. Thank you for your kind attention. Thank you.
Okay, thank you to Professor Harata Sensei. Thank you very much. Actually, when I was a student, Professor Harata is my dean in the graduate school of interdisciplinary sciences. Okay, it's truly an honor to welcome to distinguished guests who have kindly joined us today despite their busy schedules. Allow me to call our first guest, Professor Insinyur Dr. Muhammad Huzaimi Juso, the President of Malaysian Kyushu University Alumni Association, my KYUDAI, who will share his opening remarks to the KYUDAI Now Malaysia. Please welcome, Prof.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good afternoon. First of all, Prof. Harata Akira, the Deputy Director General Institute for Asian and Oceanian Studies Kyushu University, Japan. Yang dihormati Prof. Rosli Muhammad Ilyas, Deputy Vice Chancellor, Research and Innovation, University Technology Malaysia, UTM. I'm from UITM, so normally we call University Technology Mara. Okay, and then I think we have Prof. Kuchi Kimyu, Institute for ASEAN and Oceanian Studies, Kyushu University, Japan. We have Prof. Shimizu Shuzi, Vice President of Kyushu University, Japan. My colleagues, Associate Professor Dr. Abdul Halim Abdullah, Vice President of KYUDAI. Distinguished speakers, respected alumni, esteemed guests, colleagues, senpai and kohai, and all the participants of KYUDAI Now 2025. So it is a great pleasure and privilege for me to deliver this opening address at KYUDAI Now 2025 this year, which is a forum that reflects our shared commitment for bridging our research and activities in multidisciplinary aspects. On behalf of Malaysia Kyushu University Alumni Association, in short KYUDAI, I extend our deepest appreciation to Kyushu University and UTM for organizing and hosting this important event. Ladies and gentlemen, KYUDAI Now is not merely a program. For us, it is a reflection of our long-standing bond with Kyushu University and the values we continue to carry as alumni, which are curiosity, excellence, and international collaboration. KYUDAI as alumni is an official alumni network for all Malaysian graduates of Kyushu University, Japan. So we build on the foundation of shared experience in Kyushu and beyond. So KYUDAI connects alumni across generations, fostering lifelong friendship, meaningful partnership, and global engagement. So for KYUDAI itself, we have our missions, which are, some of them are to reconnect and unite KYUDAI alumni not only in Malaysia, but worldwide. We would like to share news, opportunities, and inspiring alumni stories through various platforms, including our social media. We would like to support academic, professional, and cultural exchange between Malaysia and Japan, and also to strengthen our relationship with our beloved Kyushu University. As a president, I see the members of KYUDAI Now and KYUDAI right now is not only a participant to this event or as a former students, but as ambassadors of knowledge diplomacy, contributing actively to society in academia, industry, government, and beyond. And then the theme of this forum is timely and forward-looking. As the world faces increasingly complex challenges, from climate resilience to technological transformation, it is clear that interdisciplinary cooperation is essential. So, ladies and gentlemen, we believe that KYUDAI Now that we are organizing right now in 2025 will serve as a launchpad for such collaborative efforts. Let me take this opportunity to invite all alumni and partners, as well as the participants for this KYUDAI Now program, to keep supporting in KYUDAI activities. We can mentor and support our younger KYUDAI graduates. We could explore research partnership and exchange initiative with Kyushu University, and continue being proud voices of KYUDAI legacy in Malaysia. Together, let us carry forward our shared mission, which are to strengthening ties, building trust, and shaping a better tomorrow. I'm just given 5 minutes for opening speech, so the MC looking for me giving a positive cue to end up my speech. So in closing, I once again thank Kyushu University, UTM, and all contributors to this forum. May this event spark new friendship, new ideas, and new opportunities for impactful collaboration between Malaysia and Japan. With that, thank you. Arigatou gozaimasu. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much to the Professor Huzaimi. Next is a great pleasure. I would like to invite Professor Dr. Rosli Muhammad Ilyas, Deputy Vice Chancellor, Research and Innovations, University Technology Malaysia, to deliver his opening remarks for KYUDAI Now Malaysia. Prof, please.
Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon. Prof. Shimizu Shuji, Vice President of Kyushu University. Prof. Harata Akira, Deputy Director General, Kyushu University Institute of ASEAN and Oceanic Studies. Professor Muhammad Huzaimi Yusof, President of Malaysia Kyushu University Alumni Association. Professor Kikuchi Kimio, Kyushu University Institute of ASEAN and Oceanian Studies. Professor Zaini Ahmad, Dean Faculty of Mechanical Engineering, University Technology Malaysia. Distinguished guests, professors, industries, representatives, esteemed colleagues, and dear students. On behalf of University Technology Malaysia, it is truly my honor and pleasure to welcome all of you to Johor Bahru for Kyushu University Forum KYUDAI Now, held in conjunction with the Campus Asia Plus Summer School 2025 in Energy and Environmental Science and Technology. First, allow me to express my sincere appreciation to Kyushu University and its Asia and Oceania Studies Education Organization, Q-AOS, for leading this meaningful initiative. And to our valued partners from Busan National University, Shanghai Jiangtong University, and our dedicated faculty members at UTM. This collaborative effort embodied the true spirit of academic partnership, where borders do not limit knowledge and where learning transcends geographical boundaries. The KYUDAI Now Forum is a dedicated platform designed to strengthen academic and institutional ties between Japan and Malaysia. Jointly organized by Kyushu University and the Malaysia Kyushu University Alumni Association, KYUDAI, the forum brings together a vibrant community of faculty members and researchers from Kyushu University, alumni, and representatives from universities, industries, and government bodies. Its core mission is to reinforce the alumni network that connect Kyushu University with Malaysia, while facilitating meaningful networking among academics, industry leaders, and policymakers. Through this exchange, the forum fosters dialogue that inspire innovation, collaboration, and shared progress. It also promotes interdisciplinary joint research and educational partnership across diverse fields such as engineering, medicine, agriculture, and environmental science, advancing knowledge and impact across borders. Today, KYUDAI Now event serves as a showcase of the impactful work being done with the Kyushu University network and its partner. It is more than a sharing session. It is a bridge connecting institutions, disciplines, and culture. We hope this forum provides exposure to cutting-edge research from multiple top-ranked universities, opportunity for cross-disciplinary learning, allowing participants to see problems from different perspectives, direct engagement with international experts, enabling meaningful discussion and mentorship, and strengthening institutional ties that may lead to joint grants, publication, and student exchange program. For our students, this is an opportunity to learn directly from distinguished academics and to be inspired to pursue their own research ambition. For our researcher, it is a chance to connect with like-minded experts and experts and explore joint projects that can make a tangible difference to society. To all our participants, especially our international guests, I encourage you to embrace every moment of this program, learn from one another, ask questions, share your culture and build friendship that may one day lead to impactful collaboration. While you are here, I also invite you to experience Malaysia beyond the lecture halls. Try our local dish, enjoy the warmth of our hospitality and capture the beauty of Johor Bahru. These experiences will add a personal dimension to the knowledge you gain, making your journey here truly unforgettable. I hope that through this program, each of us will be empowered with the knowledge, skills and connection needed to shape a better, more sustainable future. Thank you once again to all our organizers, partners and participants. Wishing you a wonderful forum and a truly memorable stay in Malaysia. Thank you very much.
Okay, thank you very much, Professor Dr. Rosli. Okay, ladies and gentlemen, to give us a comprehensive introduction to Kyushu University, and now may I invite Professor Kimio Kikuchi from the Institute for Asian and Ocean Study, Kyushu University. Professor.
Thank you very much. My name is Kimio Kikuchi. I'm from Kyushu University Institute for Asian and Oceania Studies. So today I'd like to introduce our Kyushu University and also our institute. I'm very honored to present this very important information. Okay, at first I would like to introduce where Kyushu University is. So Kyushu University is located in Fukuoka Prefecture, which is in southern area in Japan. This place. And Fukuoka Prefecture is a very famous place for visit. So, for example, there are Kyushu City, which is very famous for a night view, beautiful night view, and Hiroshima City, which is quite close to our campus, very nice seaside, and also Dazaiku City, which is famous for a very historic shrine of the god of learning. And also Fukuoka Prefecture has many local food, delicious local food. And Fukuoka City is the capital city of Fukuoka Prefecture. It is 6th largest city in Japan. And then this is very close to other Asian countries, so we call it like a gateway city to Asia. Fukuoka City, we Japanese like very much this Fukuoka City. So this has been #1 for 5 years as a place where Japanese people want to live and go to and work in. And international people also like Fukuoka, seems to like Fukuoka City, and it has been #1 for almost 5 years as a increased rate of foreign residents. And then also it was 5th among Japanese cities that has highest increase in number of foreign residents. And Fukuoka City is also notable among Asian cities. Like according to the statistics, Fukuoka City is the second most comfortable city in other 13 Asian cities. So one of the reasons of this result is that relatively good weather, having a lot of sunshine days. And now, from now on, I'd like to introduce Kyushu University with some metric information. So Kyushu University is one of the 7 former empire universities, and it was established in 1911, so it has more than 100 years history. One of the very features of campus, which I would like to show, is that the main campus of Kyushu University has the largest campus in Japan. So it's approximately equal to 425 soccer fields. So this picture is the Ito campus. So you can see Ito campus, but you cannot see it's just a part of Ito campus. So there is a place where you cannot see in this picture. So the long is almost 3 kilometers, and then wide is 2.5 kilometers. And this is our main library, which has one of the biggest book collections in Japanese universities. Not only Ito campus, but also Kyushu University has 3 other campuses, like Hospital campus, and then Ohashi campus for art and design, and Chikushi campus for sciences and engineering. So Kyushu University is one of the very important university in Japan. It's one of the 10 designated national universities in Japan, which is selected for its strong education and research background. And as a ranking, Kyushu University is 7th in Japan, according to Q-AOS World University Ranking. And they're also 5th in Japan, according to English Times Higher Education. In Kyushu University, there are 12 undergraduate schools and 19 graduate schools. And the total students number is 80,800. And the faculty is more than 2,000, which is equal to the ratio of student to faculty is 9:1. So we can say that a relatively few number of students with that low number of students per faculty member, we can offer education and research tailored to each student. Regarding to international students, actually it is 2,569 in 2024. It's approximately 14% of all the students. So 1 out of 7 students are international students. And the number is growing every year. The international students number is growing every year. So we welcome you to come to Kyushu University for your study. And the international students come from 109 countries and regions to Kyushu University. And we have to support those international students who want to come. We have 10 overseas branch offices in the world, and we have 5 in Asian countries. And Kyushu University has to accelerate the collaborative collaborative activities with other international universities. We have agreement with almost 300 foreign partner universities for student exchanges, and more than half are from Asian countries. Like in Malaysia, we have such 2 universities. We have a university level exchange agreement. And then for faculty levels, we have 4 universities and departments. Of course, here, like University of Technology Malaysia, we have an agreement. And also, as a research, the faculty member, they have obtained more than 12.5 billion research funds. And then this is approximately equal to 83 billion US dollars. And the articles published by our faculty members have been cited more than 290,000 times. And then there are many patents obtained faculty members of Unused. And now I would like to briefly introduce our institute, Institute for Asian and Oceania Studies, the organizer of this KYUDAI now. So our focus is on 3 points, such as interdisciplinary action and on-site and on-demand, and future SDGs. So as an interdisciplinary action, what is most important one is the kind of research consortium. So we offer, our institute offer faculties and faculty members and researchers the place for exchange their research and their experiences so that they can be inspired by the other researchers and then create another new innovations. And another very important activity is Groundwork Seminar, which is online seminar, weekly online seminar, and then offered at the lunchtime. This is for free, of course. And then this seminar was offered by the faculty members of Kyushu University or other universities in Kyushu area, island area. And then you can hear the very cutting edge information and research from the experts of that domain. So this time, this week, we have also Wednesday seminar. This is very memorable seminar of 200th seminar of this seminar. So you can also have access to this seminar. If you visit our homepage, you can find a place where how you can visit. And this is not because of the time difference in Malaysia. You have you can see from 11 o'clock. It's not lunchtime, but you can enjoy it. And of course, this seminar offered by we offered English simultaneous translation, so you have no worry about Japanese. And another one is another important activity is Asia Week. So this is a week of events. There are many opportunities of symposium or gathering or events or forum. So every year we have also, so this Asia Week is related to anything about Asia and SDGs. So this week, this year, we will have it in November, from November 3rd to 9th. And most of the events are offered by online, so you can also have an access from this homepage, from our homepage. And then finally, our most important activity is KYUDAI Now, as you present today. So I will show some pictures of KYUDAI Now. This is KYUDAI Now in Thailand, Mongolia, and Egypt, even we had in Egypt. And this year in March, we had Vietnam for the first time, and in Singapore for the first time. So that's all my presentation. Thank you very much for coming today and enjoy the presentation, networking, and dinner reception. Thank you.
Okay, thank you, Professor Kikuchi. Okay, before we proceed for the group photo sessions, I would like to once again to invite Professor Harata to the stage to present the token of appreciations from Kyushu University to our honor guest, Professor Dr. Hussein, and also Professor Dr. Rusdi. Please come. Next, Professor Dr. Hussein.
Exchange. After this. Oh, after this. After this. Yeah. Okay.
On behalf of my KYUDAI,
will be the moderator for this session. So we will now begin the session number 1 for environment, the topic of environment. So in this session, we will hear from 3 distinguished speakers from Kyushu University and 1 speaker from University Hussein on Malaysia, UTHM. So who will be sharing their research and perspective on environmental sustainability. So each speaker will be allocated approximately 15 minutes for their presentation and followed by a 5 minutes Q&A session. And we kindly seek everyone's cooperation in adhering the time allocated so that our program may proceed smoothly. So to begin, it will be my great pleasure to invite Professor Homan Prazaneh to deliver his presentation entitled Towards a Sustainable Electricity Market in Japan. Please welcome, Prof.
Okay, good afternoon everyone. My name is Homan Prazaneh. It's a great pleasure and honor for me to be here. And I would like to express my sincere thanks to the organizing committee of KYUDAI for having me here. The title of my today's presentation is basically about towards the sustainable electricity market in Japan. Can you hear me? Yes. So before starting, let me explain about ourselves, our laboratory, and who we are. Basically, we are based at the Kyushu campus, one of the campuses of Kyushu University, and we belong to Interdisciplinary Graduate School of Engineering Sciences, ICSIS, which has basically 6 majors, and we're working under mechanical and systems engineering, right? And there are several departments, including the Department of Energy and Environmental Engineering, that we have several laboratories. So this is basically my laboratory, Energy and Environmental System Laboratory, that I established since 2018, when I moved from Kyoto University to Kyushu University. Okay, so let me briefly explain about our research. Time is too limited, I try to explain it rapidly. So the main core research is about the energy and environmental systems. We're doing basically system analysis. So we're working on energy and environmental system modeling, right? So our special focus is given to the electricity market. I will explain today, especially jets. And on the demand side, we're focusing on demand response programs. On the supply side, we're working on integration of renewable energy. And so to link supply and demand, we are working on electricity market analysis, both wholesale and local energy market. Part of my research is about the environmental impact assessment. It's about the co-benefit assessment. I explained this last year, I think, in one of the KYUDAI events. So this year, I will explain about our research, which is related to electricity market analysis. Okay, let me explain briefly about basically the historical liberalization of electricity market in Japan. For those who are not familiar, the liberalization has been started since 1995 by introducing the independent power generators and also bidding system and demand aggregators. This is the first stage. In the second stage, in 1998, the market was liberalized for the big consumers or generators over 2,000 kilowatts, right? And then in 2004 and 2005, it was liberalized for these small communities, like the buildings, households with less than 5,000. And here we have the wholesale market, including chips. And then in 2008, the Japanese introduced the day-ahead market. So you may know what's day-ahead market. The bidding system is like this, that the market is cleared next day for every 30 minutes. So the demand quantity, the supply quantity, and the price is basically set for every next day for every 30 minutes. And in 2016, the whole search market was liberalized. So we have 9 power companies in Japan, including TEPCO, KEPCO, and Tokyo Kansai, and different areas. So this is the general structure of the wholesale market in Japan. So you can see the main generators, then we have 9 actually service providers or power companies. Then there is OCCTO, which stands for Organization for Cross Regional, Coordination of Transmission Operators, as private entity, who is responsible in managing the national level and regional level for market clearing. But the main operator is JEPS, Japan Electric Power Exchange, right? Which can offer different types of the bidding system, like the price-based or forward or spot market. What we are doing in our laboratory with respect to JEPS, our research can be categorized in 4 main categories. The first research is about synthesizing the clearing mechanism in Japan Electricity Market Exchange JEPS. Remember that this market is a bit different from the regular market because we have day ahead, so everything is based on forecasting for next day, right? And then also we're focusing on the rule of the virtual power plant as a part of the market or even as a price taker, whole market. We are also focusing on demand response program on the demand side and the hybrid local energy market. This is the structure of the model that we developed since actually 2019, which includes all of the generators you can see here. It can be applied to 9 main regions in Japan. We have the demand aggregators and either prosumers, which can consume and produce electricity. And then we are working on mimicking the operation of the wholesale market operator, which is JEPS here, through developing different optimization and data science-related work, right? And on the right side, we have the local energy market, which is part of this market as a community base integrated with the national level, but also we have peers here, and the peers can exchange data and information with each other, right? So here, all of research is about the integration of economy, environment, and social, the spot market with renewable energy integration, and also the customer load patterns. This is some of the results that I can share with you. If you are familiar with the market clearing mechanism, so you can see this is the equilibrium chart. Then you can see the supply quantity and demand quantity, and it gives you the price at different hours for different regions. This is really important because when you look at this chart, you can understand how the integration of the different sources can change the price of the market. So you're expecting next day. You don't know anything about next day. So you just know, you can just predict the demand and supply of electricity. And then you need to forecast the power generation from the different renewable energy generator. Then by this model, you can actually estimate the spot price. So this is very helpful for the market operator. So we're using this model for actually different strategic plan, like the 2013 strategic plan, and also to study the price spike in the market, especially during the COVID-19 era that we have big changes in the market. So about the local energy market as one of the solutions, so we're focusing on the hybrid market, which is very important mechanism for decentralizing the market. It's about the customer centric focus, and it's really important for enhancing social cooperation. What we are doing here, you can see in this framework, we're working with big data on supply side, price data, and also hourly meteorological data. And then we combine all of this to estimate the renewable energy generation. On the other side, we have the customer side. So focusing on demand behavior through introducing different utility function, risk function, to mimic exactly and precisely the customer behavior. Then we have social welfare maximization model, which tries to maximize the social welfare for all actors. And finally, you can get the optimal balance between the market actors, producer, generators, and the point of the price and optimal price point. This is one of the examples of the application earlier in Tokyo. We applied the IEEE class. So you can see we have 3 communities with different demand. It's about 30% of total Tokyo demand and generators, and then how the generators has been allocated in different locations. And this curve shows the contribution of the different resources. Here we have PV and DG or diesel generator with respect to dynamic change in price in JEPs and also dynamic change in actually customer demand. So we can have this kind of chart in different regions. And this gives you the price of the market. You can compare the local electricity market and JEPs price. Sometimes you don't access to electricity generation from renewable energy, you follow the JEPs. When you have access to renewable energy, then you can generate electricity. So the price is different from the JEPs. So these are valuable actually results that will give us clear insight about the market, and we can forecast the market for next day. The third part of my research is about the demand response. So it has 2 ends. The first end is about the renewable energy generation. We are using AI like the LLM and LSTM and other methods like deep learning. On this demand side, we're focusing on microeconomics basically. And then we're focusing on price elasticity of demand. I have no time with it. And then again, what we are doing is to see when you change the price, when the operator changes the price, how the customer changes their demand behavior, right? But remember that for the customer, it's really important. Sometimes, so the operator will ask you, for example, to cut your electricity based on the contract. But at the same time, you're watching the football match between Manchester United and Barcelona. So you're not really interested to do it, right? So it's all about the customer satisfaction, right? How to model this. Then we conducted a quick research, 2 years. We collected data for different cities in Japan in collaboration with a Rakuten company. So to see that what feature will affect the customer satisfaction and to extract the empirical equation to show the customer that has satisfaction, considering different actually features. So here is the result that I can share with you about the price-based demand response in Tokyo. We learned that we can get 1.6% electricity reduction if we apply price-based. And this is about the customer satisfaction with different features. And we learned that the Japanese people are really interested in or really sensitive to environmental protection activity to engage in the demand response market based on the data that we covered and collected in 2 years. This is a good map which shows basically the operation of demand response in all 9 regions. Some regions like Tokyo, they have more demand, they are more sensitive to demand response. In some regions like Kyushu, they have more renewable energy, they are less actually sensitive to basically to demand response. But the change in peak demand is from 1.9% to 7.8% in different regions, right? 3 minutes, okay. So this is our recent research, which is really new, application of demand response in hybrid renewable energy. We proposed this idea and the model, you can see this Johor applied energy. I suggest you, if you are interested in this field of research, please refer to this paper. We clearly explain the model and the result that you can get. Finally, for the experimentation, we have developed the indoor microgrid system model, which is connected to the target machine, and we're focusing on control system. The control system helps us to see how the price change and demand change will affect the microgrid operation. These are some of the papers that we recently published. I invite you to read them, and if you are interested about the basic principle of modeling of the electricity market, you can read my book, and thank you very much for sharing your time.
Thank you both for the interesting presentations. So we are in the Q&A session for 5 minutes. Is there any question from the floor for this topic or for this presentation title? Any questions from the floor? Maybe Prof, one question from me. So what is the main challenge to maintain or to sustain the electrical market in Japan?
There are several challenges, right? So the first thing that we have no actually clear information about the customers, right? So that's why part of my research is to explore what are the main factors which affect the customer behavior, right? So this is really important. Because when you discuss the market, it's not all about the generation. Sometimes you have fuel, you can generate electricity, right? Or how to share this electricity with the customers, right? And then this kind of sensitive analysis or detailed analysis will help us to understand, okay, what are the main features, right? So I think the main challenge for this kind of research is the social part, when we discuss the customer part. And of course, if you ask me about the whole, the basic Japan electricity market, integration of renewable energy is one of the top priority, and I think the government now is focusing on integrating more and more renewable energy to enhance the grid stable.
Is there any questions? One more question from the floor? Okay, is there is no any question? Thank you very much, Prof, for your presentation. Please give a big applause to Okay, now I would like to invite our next presenter. So I call upon to Professor Osama Al-Jamal for the presentation entitled Innovative Nanotechnology Approaches for Environmental Cleanup and Energy Generation. Please, Prof.
Okay, Assalamualaikum. Good evening, everyone. I'm happy to be here today with you. And my name is Osama Al-Jamal from Kyushu University, belong to the Intensive Graduate School of Engineering Science. Today I will try to touch the topic how to use nanotechnology to improve the environmental clean up and increase the energy recovery. So shortly I want to introduce myself. I'm trained as a civil engineer before, and then I joined Kyushu University in 2004 for master. We have moved to the doctoral course, which this one obtained from Oxide campus, the old campus of Kyushu University. Then I did my PhD here in Ito campus, followed by the GSPS postdoctoral, and all of this was in the graduate school of engineering, Kyushu University. After that, I started working with Kyushu University as a associate professor in Oxide campus, then switching to the Chukushi campus in 2014, and currently I'm fellow professor from this year, April. My research all under the environmental engineering. Within this period also I have international collaboration. I visit the University of Waterloo in Canada for several months, as well as the University of Oxford in the United Kingdom to collaborate our research. So as mentioned before, we have in the Kyushu University 19 graduate schools. Kyushu University is one of the leading research progress in Kyushu in Japan actually, and one of them is International Graduate School of Engineering Science, which I belong. So this school is located in Chukushi campus, very unique and beautiful campus. The good thing about this campus is really convenient and located just near to the downtown. So if you arrive to Fukuoka International Airport, 5 minutes by subway, you will be in the downtown Hakata City. Then another 10 minutes, you will arrive to the Chukushi campus. So please visit Chukushi campus in future. You can see the all seasons in Chukushi campus. Very beautiful. This is Sakura and spring. Summertime changing to the green, then autumn, yellow, red. and in the winter we have a little snow, not too much. And in EXIS, the Interdisciplinary School of Engineering Science, as mentioned, whom I had seen before, we have like a 3 area of research considering the material and energy and as well environment. So about 65 laboratories work with these 3 topics. One of them, my lab, Water and Environmental Engineering Laboratory, we call WHEEL. In WHEEL, we have multi-international researcher team from Japan and international everywhere. And in this lab, we focus in the 2 themes. The first one, water treatment, and the second one is energy recovery from the waste. And we try to use the advantage of nanotechnology in this part to improve the efficiency of the water treatment system as well as to increase the energy recovery from the bio waste. So in particular, our aim here is to develop a novel nanotechnology-based method for environmental remediation, resources recovery, as well as renewable energy. In the water treatment side, we focus to recover nutrients from the water, such as nitrogen, phosphorus, ammonia, and so on. Remove the heavy metal from water, organic matters, antibiotics, microplastics, especially we focus with the coexistence of microplastic with the other contaminants. How can we deal with that? And recently we start with new project to remove the PFAS from the water. In this site, we use the anaerobic energy or anaerobic digestion system to increase the biogas production, and we focus more to increase the hydrogen production rather than methane and carbon dioxide. So also we use the microbial fuel cell technology to produce direct electricity and hydrogen. So maybe the main aim for our research to reframe the wastewater as a resources. So wastewater we consider as a waste, but actually can be considered and reframed as a resources. So if we think about the wastewater, and we able to treat the wastewater to obtain the clean water which can be used for agriculture activity and irrigation system. And in the recovery side, we can recover the nutrients, phosphorus, ammonia, and nitrate, and so on. Then we can produce fertilizer which can be applied for agriculture. Then in this case, we can produce food from the wastewater. In the other side, if we can develop some system to recover the energy, the electricity, the chemical energy stored in the wastewater, maybe we can get some energy or electricity for the system. And actually, the energy stored in the wastewater is about 10 times more than the necessary energy for this treatment or this processing. So if we improve the efficiency of this system, probably we can recover all the cost of the system and have some extra. I will show some example here about the treatment of the water. The first one is here we developed the 3-dimension lab-scale aquifer system. We want to investigate the possibility of removal of chromium, especially the hexavalent chromium from the groundwater. And in this case, we use the injection technology by inject some nanomaterial into the groundwater, and we operate this system to see the possibility. Then we found out there is a high possibility to use this material, nanomaterial, to remove the chromium totally from the groundwater by injection of nanotechnology. We also clarify the mechanisms which work to remove the chromium to the water, including the electrostatic absorption and reduction and co-precipitation as well. So then we publish this information in this journal, if you're interested, Chemical Engineering Journal, one of the best in our field. You can just visit and see more information about this research project. Another thing, we also try to develop a protocol design system to design something called variable reactive barrier. This barrier can be used to clean the shallow groundwater, remove the contaminant from groundwater. We can add some reactive material here, and groundwater flow through the barrier, and contaminant can be removed. So we designed several scenarios using the lab scale system, and finally we can see that the maximum removal can be obtained by the injection technique into the barriers, and we also clarify the mechanism. In this project, we use phosphorus as contaminant or nutrient to recover and remove from the ground. Actually, this also information published in the Journal of Molecular Liquid. If you're interested, you can find too much details. Each paper here needs about 6 months to 1 year experimental work. So we cannot summarize now. And this work was part of the collaboration with the University of Oxford, as I mentioned, with the Professor Ian from the Department of Engineering Science. So energy recovery also, we use the microbial fuel cell. This is some technology relatively new, but still we need to do many, before to improve this technology. Basically, the microbial fuel cell has two chambers, the anode chamber and cathode chamber. So we supply here the wastewater or organic waste into the anode chamber. Then microbes, bacteria, will degrade the organic matter and produce electron due to following this biochemical reaction. Electron will throw or flow through the circuit, and then we get the electricity from this circuit, and in other side the cathode will collect the electron and the proton and form water. So this device can produce water and electricity. So in this part we add several nanomaterials to improve or use them as a catalyst to improve the efficiency and biodegradation process and increase the current. So from that study, we able to increase the production of electricity more than 400% comparing with the control system, and also we improve the removal of the groundwater or degradation of the organic matter about 25%. So this information also published in the energy conversion and management. You can find more details here. Another project about the anaerobic digestion technology. In this project, we introduced the nanomaterial into the anaerobic digestion system. We investigate and test several material. The result or the outcome show that we able to increase the recovery of biogas 120% comparing to the control one, and also the methane production increased about 122, and the total biogas increasing 195% comparing with the control. This information also published in the Renewable and Sustainable Energy Review, and this title you can find also more information. One thing here before my finish, I would like to just let you know, every year in Kyushu campus, we organize in October this conference which is called International Exchange and Innovation Conference on Engineering Science, IEICS. This is Scopus Indexing Conference. This year will be held in October 30-31st, 2025, the 11th edition of this conference. And the submission deadline, of course, already passed May 31st. This year we received about 400 papers and 300 accepted, maybe about 80 papers from Malaysia. So we expect 80 people or more will join this conference this year in October. For next year, we will have this conference again for 3 days, starting from 27, 28, and 30 of October 2026, the edition 12, and the deadline will be same May 31st, 2026. So if you're interested, please submit your paper before this deadline. I mean, this is no extension for this deadline. Okay? And that's all from one thing else we have. This conference is free registration. You don't need to pay any money. Just join and do your presentation. And if you're interested to know more about this lab, my lab, you can just scan this QR code and you can find more details about this conference and my lab research. And thank you for your attention.
Thank you very much for the presentation. So open to the floor for any question for our presenter. Yes.
Professor Osama, thanks for your talk. I noticed your research on using nanomaterial for chromium removal. From a civil engineering background perspective, how practical it to apply these nanotechnologies solutions in large scale water treatment, wastewater, especially in developing countries?
Yeah. Thank you for the question. Yeah, this is a good question. One thing about the nanomaterials is has some huge surface area compared with the bulk material. So when we increase the surface area of those material, we can increase the efficiency and minimize the amount of the material as well as the cost of the material. So sometimes when we say nanotechnology or nanomaterial, the people believe or thought that it's not possible to apply in the developing country. Actually, this is the good solution for the developing country because the rich country like Japan and USA and Germany, they have another technology like, for example, reverse osmosis technology, which is very, very expensive and sometimes is not applicable in the poor country. So the nanotechnology is another solution, another option which is cheap, but we need to have some, because this is relatively new, right? We need to do some design system or protocol system to operate and manage that things. So we need to do more research, I think, in this part to make it more practical and more economic. Yeah.
Okay, thank you very much. Another one more question, I guess, maybe from participants. No questions? Okay, all right. Thank you very much again. Thank you, Prof, for your presentation. So I would like to call for the next presenter, Professor Michitaka Otaki, who will deliver the third presentation entitled Oxide Thermoelectrics for Recovering Unused Thermal Energy. Please, Prof.
Good afternoon, everyone. I'm Michitaka Otaki from Kyushu University, Japan. And I'd like to talk about something a bit about my research work, and also at the last of my talk, I will share my time with the other two professors, Professor Kigai and also Professor Hamamoto, also introducing their own research work really shortly, briefly. So, the title of my talk is, as you can see here, Oxide Thermoelectrics for Recovering Unused Thermal Energy. So basically, thermoelectrics or thermoelectric power conversion is one of the major field in my research work, and which actually probably you know the thermocouples as a thermometer. So it's the same principles, but the thermocouple is made by two different kind of the metal wires. And the metal is good for the measurement for the voltage, but not suitable for the power generation. If you replace the metal wires to the different type of semiconductors, you can obtain much larger voltages, and it can be suitable for more suitable for producing the electricity or electricity powers. That's what I'm working on. So, okay, first of all, this is my introduction. So I'm already too old, so I have no room to accept any new student in my lab and myself. So probably my associate professor, Professor Syed, can accept you if you are interested in my work. And I was born in Sweden, but I came back to Japan when I was 2 years and 8 months old, so that I remember nothing. So my English is completely made in Japan, actually. And my hometown is Yokohama, but I moved to Kyushu of Fukuoka right after I get the PhD in University of Tokyo. And in the student time, my research topic was actually an organic polymer science. However, I moved to the laboratory in Kyushu University, which are working on solid state inorganic chemistry. So I changed my field completely from the organic polymer to solid state inorganic, from the solution to solid, from the maybe up to just 200 degrees Celsius to up to 1,000 degrees Celsius. Anyway, so since then, I was in the same place in campus, Kyushu campus, for 35 years or something. And 1.5 years later, I will retire actually. So anyway, this is one of the well-known, we call this a Sankey graph. It is actually energy flows in the world in the year of 2021, quite recently. So on the left-hand side, you can see the energy input or primary energy supply in the society. And then they will go to each industrial sectors, each of them has its own energy conversion efficiency. So if you sum up all rejected energy or unused energy, that is actually more than half of the total energy supply. So we are wasting more than half of energy every day. If you look at the situation in Japan, current situation is a bit worse than the world total. Because after the Fukushima power plant crisis in 2011, in Japan, nuclear power plants is almost shut down. So we are more relying to the fossil fuels, and we are actually buying them from the outside of Japan, paying so much money. And these energy also go to the industrial sectors, and the wasted energy is more than 60%, almost 2/3 of the total energy supply is we're wasting. So this is huge amount of energy resource, potential energy resource we currently have. But they are the reason why we are wasting them. It's very difficult to use actually, because the waste heat energy is usually, I would say, widely spread in the society. Each of them are not so large, and also temperature can be very rather, I would say, small. It means the lower exergy. So this difficulty actually makes them unused. So, but anyway, this is very, I would say, we call mottainai in Japanese. So we have to think about how to utilize them, even at least a part of them. So if you consider the amount of this energy, the number is in the unit of the petajoule. So 11,000 petajoule correspond to the power generation capacity of the 184 station of the 1 gigawatt class nuclear power plants. So in Japan now just more than 30 power plants exist, but in just maybe 10 or something is just working on. So you can see the huge amount of energy we currently have as a potential energy resource. So one of the ways to utilize the waste heat energy is to use the thermoelectrics, which I said that they are kind of the thermocouple. But in this case, we use P-type and N-type semiconductors as a pair. We call this kind of the pair as a unicouple. And if you apply temperature difference, delta T, across this device, you can observe thermoelectromotive force or voltage, which is proportional to the temperature difference, delta T. And the coefficient of the proportion S is called the Seebeck coefficient. Larger Seebeck coefficient means you can get larger voltage per unit temperature difference. And the interesting thing is that if you, in this case, you apply the temperature difference here, and you can observe the voltage. But also you can connect the battery to these two terminals. Then direct current will flow through this circuit, and then you will observe absorption or release of heat at the junction. This is called LTA effect, and the widely utilized to particular cooling applications. And this application is very convenient because the amount of heat absorbed here is proportional to the amount of the current. So you can change the current very easily by, I would say, using some voltage or voltmeter or something. And also you can switch the direction of the current. Then the heat flow also switch to the direction. So you can control the temperature here or cooling here or heating here very, I would say, handy. You can control that. So, and in particular, this civic effect or civic mode is very useful to filter the temperature difference or waste heat to convert into the electricity. So this is summary of the maybe a bit smaller letters of the summary of the characteristics of the thermal conversion. So anyway, this is direct conversion from the temperature or gradient to the electricity using just solid devices. It's all solid device, so it has no moving parts, no rotation, no vibration, no noise. And it's all solid, so you can make it very thin, very small, and also it can fit to any size or shape of the heat source. And also it's scalable. And so the temperature mode is very good for non-CFC cooling technology. And the civic effect is very suitable for recover decentralized or widespread waste heat energy in a society to mitigate fossil fuel consumption, also CO2 emission. Another point is that here the ZT is the value to evaluate the performance of the device or material. And the T is temperature, average temperature of the operation. So the Z consists of the 3 parameters. S is civic coefficient, as I said. Also sigma is electrical conductivity, how easy the current can flow through these materials. And copper is the thermal conductivity. So the larger S, larger sigma, and also smaller copper is necessary to get the better materials with higher GT values or D values. But actually, these 3 parameters are all a function of the carrier concentration. So if you can have the larger amount of electron in the material, you can both have higher electrical conductivity. But also, civic coefficient will be smaller. So these 2 parameters, S and sigma, are always compromising each other. And also, copper, thermal conductivity has 2 major components. One is the contribution from the electrons, the current flow, and also another one is lattice vibration. So electron part is actually proportional to the sigma electron conductivity. So we cannot decrease this electron part. So what we should do is to decrease the lattice contribution or heat, conducting the lattice vibration without strongly affecting the current conduction. It's very difficult to do. This is one of the most well-known successful applications. This is space application. You can see in the left-hand side, this is Voyager 1, which launched in 1977 when I was the first grade in high school. And this one is more newer one, so the Curiosity or Perseverance, which launched recently, and they are now on the Earth or the Mars. And they all of them are using thermal generators. Okay, so this is another more closer application in a life. This is wristwatch generated power by your body heat. This is also how to recover the waste heat in the exhaust gas in international commercial engines. And so far, conventional materials are all non-oxide. It's not telluride, red telluride, it's even germanium. And most of them are the compound of the heavier elements. And these compounds are usually focus heavy and also very brittle, and also some elements are toxic, and it also can be expensive. So if you really think about the recovering the waste heat in a society, we have to think about more convenient, more safer materials to much larger applications. So I have been working on oxide materials in this field for more than 30 years. But at the beginning, oxide is very unusual materials in this field. Actually, they are disregarded because they're very good at high temperature stability and also the cost and also processability. But the oxide contain oxygen, it's light element. The light element can make the lattice vibration higher or faster to lead to the higher daytime conductivity. And also, oxide is an ionic compound, so it will lead to lower telemobility. And these two inherent disadvantages of oxides actually has avoided the application in this field. However, some oxide can show these properties. These are carrier mobility. I mentioned oxide is in general show lower carrier mobility. But yes, so we have to 50 minutes.
15 minutes.
50 minutes, okay. We have okay. Then we have to hand over the microphone. Okay. Then okay. I go to the. This is not recent, but the good result about how to reduce the thermoelectric oxide by the binary doping. You can see the very drastic decrease in the thermal conductivity in room temperature, also high temperature, and it will lead to very drastic increase in Vp values from 0.3 to 0.65. And this is what happening when we dope the gallium and aluminum at the same time. You can see very drastic change in the microstructure. It can lead to the very much lower good suppression of the thermal conductivity. And this is timeline of the oxide materials. Still, Vp value is still a bit insufficient, but they are increasing. Also, here is the number of publication and also citation in year on oxide materials, and which started in early 1990s. So you can see very monotonic increase in both citation and publication. So I'd like to hand over a microphone to the Hamoto Sensei, and also to Kyushu Sensei. Sorry for not so much time. Maybe 1 minute or 2 minutes you can.
Hello everyone. Due to the limited time, I shall briefly about this slide of myself. I belong to Optoelectronics laboratory. I'm working on mainly photonic integrated circuits. One topic is for breast sensing. The other one is for laser diodes for high-speed communication. And the last one is optical modules. For more detail, I will talk tomorrow. So please allow me to go to this stuff one. Okay, next please.
Thank you very much for this opportunity. Actually, Professor Odati kindly gave me a short period to introduce my work. My name is Nanotechnology from Kyushu School of Unused. So my work is my laboratory is the Urban Environment Science Laboratory. And actually, I have a chance to give a short presentation in the last KYUDAI now. So hopefully some members will remember my work. But we are trying to our main focus is describing the effect of beam in the urban environment. So if you have any interest in the evaluation of the environment, built environment, or civil engineering, architecture and engineering, computational with engineering, experiment, field measurement, these kind of courses. So if you are interested, shall we talk in the break time? Yeah, thank you very much. Yeah. It's like a combination of the
Okay, I'd like to answer the question if you have. Any question from the floor? Any question? Not the case.
Okay, well, maybe one short question from me. How many percent the advantage, I mean the efficiency of your methods to recovering all this unused energy?
You mean energy conversion efficiency?
Yes.
Actually, unfortunately, the total conversion efficiency of the thermal conversion is currently not very high. So the highest commercialized applications such as space application by NASA is still in total maybe 7% or something. So it's due to the limitation of material, basically. So however, so particularly for US heat recovery, the price of heat source is nothing. So even how to say, a low energy conversion efficiency, if you can make the devices cheap and you can get the good energy source, I think you can get the electricity with zero ringgit. So yeah, it can be feasible, but as I said, that's one of the reasons why such convenient technology is still not commercialized in our society. Only in space application, military application, and very niche application in some remote place, like in the center of the desert or in the very deep ocean or something.
Okay, thank you for your clear explanations. So please give a big applause to Professor Alatas. So we are now in the final presentations. So I would like to call Associate Professor Dr. Nurmiza Osman for the presentations titled Biosensor for Environmental Application, Bridging Biology and Technology for a Greener Future. So please call.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon to everyone. Konnichiwa, minasan. Okay, so thank you to everyone who joined this program. KYUDAI now at Johor Bahru, especially at the University of Malaysia UTM. So today I'll be talking about biosensors for environmental applications, bridging biology and technology for a greener future. So this talk aims to introduce the principle of biosensor design by highlighting how the biosensor can be applied for environmental monitoring, and also to explore how recent innovations like nanotechnology and also Internet of Things can reshape this field. Okay, so before that, I'd like to introduce myself. I am Nurmiza binti Osman. I am now serving as Associate Professor at the Faculty of Electrical and Electronic Engineering in University Tun Hussein, Malaysia, UTHM, located at Bahru, Johor. A bit on my education background. So I have completed my bachelor's and master's degree in Electrical and Electronic Engineering at Tsunoya University in Japan in 27 and 29, and then I continued my PhD at Kyushu University in Fukuoka, Japan, which I completed in 2014, also in Electrical and Electronic Engineering. And then for my research interests, especially in UTHM, my research focuses on the intersection of electronics, sensors, and especially for the biomedical applications. Specifically, the research related to the biosensors development for health monitoring system. Like right now, our team is trying to developing a biosensing system for the sweat detection, especially to monitor the dehydration status for the human, right? Okay, and then the next research scope or research interest is for the development of a non-invasive agricultural monitoring using the pulse and current system. This one, and the third one is electronics for medical assistive device development. And last but not least, the topic is related to the application of magnetic nanoparticle used for biomedical imaging system. Right. So through these works, I aim to contribute to solutions that improve human health in general, and of course to enhance the agricultural sustainability, and also to produce and advance technologies for a greener and more inclusive future. Right. But before I continue to my talk, let me briefly introduce a bit where I come from. So I am now based at UTHM, University Tun Hussein, Malaysia. It is a technical university located in Bahru, Johor. So UTHM is strongly committed to advancing knowledge in engineering, technology, and applied sciences with an increasing focus on sustainability and green technologies. So this is the direction of UTHM, Global Technopreneur University in 2030. And then the vision is to be a global technical university in two main fields, which are sustainable technology and transportation. And the mission of UTHM is to provide technical solutions for the industries, for the communities, based on the Tauhid paradigm. Right, so in Malaysia, yeah, we have one more, but in this slide, we have 4 main universities in Malaysia, classified under Malaysia Technical University Network, or known as MTUN, MTUN. So UTHM is one of the Malaysia Technical University Network, and as I mentioned just now, the niche area is on the sustainable technology and the transportation. So generally in UTHM, we offer diverse courses from different faculties. So as you can see here, so I am based at Faculty of Electrical and Electronics Engineering, but others, we also have the Mechanical and Manufacturing Engineering, and then we have the Civil Engineering and Built Environment, just to name a few, right? And also, other than that, we have 4 Center of Studies, and also we offer the diploma degree until the Doctor of Philosophy degrees. And when we want to talk about research in UTHM, so under I2E, or Institute of Integrated Engineering, so I2E manage 6 Center of Excellences. So we have the COEs here, Center of Excellences like RESAS, EM Center, MIN SRC, ANMC, NPRC, and COE Rail. All of these COEs have their own niche area related to their own research. But the one that I can introduce to you or promote to you, the groups that are focusing on the environment related research, such as the EM Center, MIN SRC, and also the NPRC. So I have provided, actually we have a link here, Center of Excellence COE, but unfortunately I am not sure either the internet is connected or not. So my initial plan is to show you the homepage of the Institute of Integrated Engineering webpage. But yeah, you can go to the UTHM website and check further information on the 6 COE that's mentioned here, right? So these are the faculties in UTHM. So because I am from FKEE, in Malay, Faculty of KYUDAI, Electric dan Electronic. So we have the FKEE. Okay, so in English it is Faculty of Electrical and Electronic Engineering. So we offer 2 types of undergraduate program, Electronic Engineering and Electrical Engineering. And then for the postgraduate, we have the Master of Electrical. For the coursework, Master of Electrical in Research. And some programs are collaborating with international universities. We also offer Master of Science in IoT, and also last but not least, the PEE program, which is Doctor of Philosophy in Electrical Engineering. Right? So just a random view, the image of the library in UTHM. So yeah, you can refer to the webpage of UTHM to get more information of University of Malaysia. Okay, so this is the Faculty of Electrical and Electronic Engineering. All the information about the faculty can be obtained from this QR code. And yeah, without any further ado, I'd like to continue to the actual content of the talk for today. So the title is Biosensors for Environmental Applications, Bridging Biology and Technology for a Greener Future. Right. So as we all know, nowadays, we always talk about environmental degradation, for example, because everything will relate back to our health, right? So environmental degradation is one of the most pressing issues of our time. We know there are some pollutants such as heavy metals, pesticides, pathogens, industrial chemicals, wastewater, are increasingly found in our soil, in the air and water. So the pollutants not only disrupt ecosystems, but also accumulate in the food chain, posing serious risks to human health. So to address these challenges, we need some tools that can allow us to detect the presence of the contaminants quickly, accurately, and sustainably. Okay. So, but of course, we have some methods that have been used traditionally, such as environmental monitoring has relied on lab-based technique. Just to name a few, we have the chromatography, we have the mass spectrometry, we have the spectrophotometry. Of course, these methods are accurate, reliable, but they are said to be time-consuming, a bit expensive, needs highly trained personnel, and so on. But most importantly, the one thing that can be highlighted here is that because they are lab-based measurements, so they are not suitable for on-site or real-time analysis. So for many communities that facing pollution, especially those who are in rural or resource-limited area, so this will make the traditional practice or the traditional monitoring practice is not practicable. Okay, it's impractical, right? So that's why we come to a new technology or new tool where we have biosensor. So this is where the biosensors come into play. So as for general sharing to everyone here, we always use sensor to detect everything. We use the thermometer to detect our health or body temperature, for example, right? Or we use some sensor to detect the saturated oxygen from inside our blood, for example, SpO2 detection, for example, right? But those are not using any bio-recognition element, so we cannot call them as biosensor. So what makes different for a biosensor to a normal sensor? So we have biosensor as an analytical device that combines, the first keyword is biological recognition element with a physical transducer. So we will say that these three core components are very important to obtain a biosensor. First is bioreceptor, can be enzyme, can be antibody, can be DNA strand, or even a living microorganism, right? And then, of course, for the signal conversion, we need a transducer to convert the biological interaction into a measurable signal. And lastly, we have the signal processor to get quantifiable, real-time information about the signal that we have detected. Okay, so depending on the type of transducer, here I classified into three types of main biosensor. We have electrochemical, we have optical, we have microbio wholesale biosensors. But of course, it is not limited to these three only. Okay, we have more than that, right? So depending on the type of transducer, the first one, electrochemical biosensors, are the most widely used. We can measure the electrical signal when we have a contaminant interact with the bioreceptor. So it is very sensitive, low cost and portable. So it makes, they are good for detecting heavy metals and pesticides. And other than that, we have the optical biosensors and also microbio wholesale biosensors. Alright. So optical rely on light signal, while the microbio biosensors use the living organism to produce the measurable response when it is exposed to the pollutants. Right. So these are some applications of the biosensor to monitor the environment. Of course, to check the water quality, to check the air pollution, or to know either the soil is contaminated or not. So yeah, what are the things that we need to detect, such as we have the lead, we have the mercury, arsenic, and so on, VOC, greenhouse gases. Okay, so these are the things that need to be detected, right? So this slide shows or just summarize a few methods: the transduction type, the principle of detection, and the example of application. Okay, how the biosensors can be used for the environmental monitoring. Okay, so some recent innovations just to share with you for the case studies. We have several examples here. Arsenic microbial biosensor, nanomaterial enhanced electrochemical sensors for ultra-trace heavy metal detection, algae-based sensors for nutrient and pesticide monitoring in agricultural runoff, and last but not least, the portable IoT-enabled biosensors to provide a real-time cloud-based monitoring. Okay. And yeah, of course, because just now we have had several presentations from previous professor related to the use of nanotechnology, right? Nanomaterial to enhance the detection level of the elements inside the wastewater, for example. So, of course, nanotechnology can improve the sensitivity, the selectivity, and can do the miniaturization of the biosensor. So, some examples that can be used are such as the carbon nanotubes, the graphene, and also the oral nanoparticle. And besides that, everyone is talking about IoT nowadays. So, we can merge the use of IoT to get the IoT-based platform to the biosensor. We can have the remote monitoring network, we can have data collection with the AI analysis, and lastly, of course, we can get the smart decision making for the environmental management. Despite the promise, the good things that we can have from the biosensor, of course, several challenges remain. We have some challenges to counterback so that the biosensor can produce or give the best measurable result as it can. Okay, so number one is biosensors must remain stable in harsh environment because we know that biosensor must deal with the fluctuating temperature, humidity when it is used on the on-site measurement. And then other challenges are the selectivity also can be an issue because of the environmental samples are very complex, may contain the interfering substances, not only the things that we want to detect. So selectivity is also the main issue. And when we talk about the sensor itself, yeah, calibration, reproducibility are also the ongoing concerns. And finally, while many researchers do or develop the biosensors in lab, and they work well in lab, but when we want to scale them up for large scale deployment in the field, so it remains difficult. Okay. Immediate solution to overcome those challenges, of course, we as the researchers are still exploring new solutions. For example, by making the synthetic biology to design the custom enzymes and microbes that are more robust and pollutant specific, and then maybe by combining the use of smartphone-based biosensors for the decision making more advanced in future. So as a conclusion, we as the researchers from various fields of research, the biologists, the engineers, the chemists, the environmental scientists, the computer scientists, okay, we collaborate across field to generate the real impact of the biosensor for environmental application. So this one is for the societal and global impact. Yeah, of course, biosensors for environmental are supporting the SDG 3, 6 and 13. So it's a step towards the sustainable environmental management to get a cleaner, a greener and healthier planet. Okay, so I think that's all for today. Thank you very much from me. So my highest appreciation to the delegation from Kyushu University. That is the picture taken by me in 2011 or 12, if I'm not mistaken. KYUDAI happening, 100 years of Kyushu University celebration. And my thanks to my KYUDAI and also UTM, and last but not least to University of Hussein Malaysia for allowing me to join this session for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for your presentation. Do you want some questions for the boss? Okay.
Good afternoon, presenter. Thank you for the presentation. I would like to ask, what are the immobilization techniques that have been used for the biosensors, especially for just now I saw there's like a microbial and algae-based biosensor.
Thank you very much for the question. Actually, for the topics that you mentioned about the immobilization, specifically for the algae, right? So that one is done by one of my team. I can introduce to you straight away after this if you want to go in detail from the Mid-SRC Center of Excellence that I mentioned just now. So maybe I cannot give you the method right now, but we can discuss it later in further, and I will introduce to you the group that work directly with the method. Is it okay? Okay. Thank you.
Okay, thank you very much. I think we have to end our session because we are running time now. So that concludes our first session. So we will now take a coffee break until 3:50 p.m. And during this time, you are only invited to visit the study abroad consultation booth, just located outside this hall. And please feel free to ask questions, engage in discussion, and enjoy some networking with fellow participants while having a refreshment. So thank you. We will look forward to seeing you back here probably at 3:50 p.m. Pleasure to invite Dr. Skorowan to deliver his presentation entitled Overview of the Open Innovation Platform and Startup Co-Creations at Kyushu University.
Good afternoon, everybody. My name is Scott Rowan, and I work for Kyushu University Open Innovation Platform, or Kyushu University OIP. A little about myself. I'm originally from Australia. I studied at the University of Queensland in Brisbane in Australia, aerospace engineering and Japanese. Then when I finished my PhD, I moved to Japan for the first time and worked in a city called Sendai, doing some aerospace engineering research. I then went back to Australia for about 15 years and worked in an engineering consulting company. And then 3 years ago, my family and I moved back to Japan, to Fukuoka. And we've been living quite close to the Ito campus, actually, of Kyushu University, just near the beach. It's a beautiful place, so if you have the chance, I'd encourage you to come and visit us. So Kyushu University OIP Corporation is a 100% owned subsidiary of Kyushu University. And it was actually established just last year in April 2024. Before that, the functions of OIP were within the university department. And so what do we do at OIP? Or why does OIP exist as a company? So partly it's the reason to have a smaller organisation that can be a bit more flexible in its planning and its execution and validation of any ideas that the university may produce. And our mission is to support the industry, academia and government collaboration that contribute to the improvement of university education and research. So Kyushu University OIP is made up of three main businesses or teams. The first one is the issue-driven team, which is focused on improving the environment for collaborative research. So it works with local industry and local companies to establish collaborative research agreements and operates on like a large scale, has a broad reach across the Kyushu region. Then there's the science-driven team, which is responsible for startup co-creation support, also technology transfer, transferring the university's intellectual property to potential partners, and then helping university researchers come up with intellectual property strategy and management plans. And then thirdly, we have the vision-driven team, which is responsible for creating industrial clusters, or I guess the overall vision for innovation for Kyushu University. So they look to develop corporation management, and also commercialisation of the university's intellectual property using all of the facets. So I'm a member of the startup driven team, and so within that team we have a number of main functions. The first one, as I mentioned, is intellectual property management and commercialisation. So in that function we work with the individual university researchers to help them identify any of their research that may be able to be protected by intellectual property, and then we help them develop a strategy to protect that IP and also consider how to develop a business around that IP. Then there's also the startup creation function. So within there we can provide funding to researchers to progress their technology or research through to a proof of concept stage. We also offer other various services such as CXO candidate matching. So CXO is a term for any member of the senior executive of a company. So it might be the CEO or the CTO, the Chief Technology Officer, or the CFO, the Chief Financial Officer. So we help our researchers to identify candidates that might be willing to work with them to establish a company based on their research. And then along with that, we also offer a number of acceleration and mentoring programs to help the university's researchers acquire the skills that they need to firstly start, but then also maintain a business based on their technology. And then putting all that together, what we're really trying to do is create startups based on the university's intellectual property, and by doing so, create a funding mechanism that allows us to take dividends from those companies and feed that back into startup creation and IP management, so that we can continue to support startups and intellectual property management into the future. So now I'd just like to talk about a few of these support programs that the university offers and participates in. So the first one is a program called PARKS, or the Platform for All Regions of Kyushu and Okinawa Startup Ecosystem. So that involves 20 universities in Kyushu and also Okinawa, and it's led by Kyushu University and the Kyushu Institute of Technology, and that program is funded by the Japanese Ministry of Education and also the Japanese Science and Technology Agency. And so what happens under that program is it provides gap funding programs and also entrepreneurship education for researchers working at any of those participating universities. So in terms of the gap funding, for a university researcher, it's available in a number of stages. For the first stage, they can access 5 million yen for 1 year to establish a business plan and identify what intellectual property they can use for the startup. And then following that, there are two other steps. Step 2-1, where they can access a further 20 million yen for 1.5 years. And then after that, there's another 40 million yen available for another 1.5 years to see the startup creation process through to the establishment of the company. Students at Kyushu University and the other universities can also participate in this program. It's a smaller scale program for students. The first stage, step 1 for a student is 1 million yen for 1 year, and then step 2 is 3 million yen for 1 year. So by accessing this program, students can work with their supervisors to potentially commercialise the technology that they've been working on throughout their postgraduate education. And so last year, so each year we hold a demo day for the Parks program where each of the research teams comes to pitch their business idea to local industry representatives and investment partners. And so at last year's event in May, this year's event in May, we had over 600 participants attend that event. So another program that's quite similar to Parks but focused on the medical and healthcare sector is called QUIC, or the Quantum University Innovation Cycle from Kyushu. Some of these names are quite innovative as well. So this one here is funded by the Japan Agency for Medical Research and Development, and it's mainly focused on universities in Western Japan, and also involves the Kyushu University Hospital Centre for Clinical and Translational Research. And so it's very similar to the Parks program. It leverages the CXO executive candidate pool and also the venture capital network that was developed under the Parks program to help researchers in the medical and healthcare fields explore the creation of a startup based on their research.
Next one, funny there.
So one of the unique programs that we offer at OIP under the Parks program is called the EIR program, or the Entrepreneur in Residence program. So you may have heard about entrepreneurs in residence being part of a company where they work in a company to help the company explore ideas for establishing startups based on their current business. Normally, what happens is, in a general business, the EIR will work within the company while still performing their other role, and then at some point, the company and the EIR will decide to start a business. The other approach is where the entrepreneur leaves their previous role, looks around for another opportunity to start a business with some other team members, and then creates a startup. So in Parks, we have a slightly different model where we have a number of entrepreneurs in residence who are employees of Kyushu University OIP. And what they do is look at all of the different research projects that are working under the Parks program and identify those research seeds which they think are a good fit for their knowledge and experience. And then what happens is they'll actually join those teams and help them prepare their applications for the Parks program. So whether it's step 1 or step 2, it doesn't matter. They will help them prepare their application, in particular, help them with market research and developing their initial business plan. And then if the project is successful and then eventually that project proceeds to starting the company, that entrepreneur in residence may actually join that business in a part-time or full-time capacity and stay with the business as it is established and grows. So at the moment we have 3 entrepreneurs in residence at Kyushu University OIP, which work with the startups to establish those businesses. Okay, and so this is just quickly about the CXO bank, which I mentioned before. So this was actually a program that was started by Fukuoka Prefectural Government, and Kyushu University has been working with them to establish this program. So at the moment we have over 700 candidates in the database, which universities from the which researchers from the university can access and look to find a potential candidate to work with them on their business. And then one of the most recent initiatives which we've established is something called the Innovation Challenge Fund. And so this came about because we realised that the existing funding programs we have have limitations. Some of them have set time limits you have to work to, or set topics that you have to conduct the research under. And so the Innovation Challenge Fund was established to provide supplemental funding to researchers to help them get to that proof of concept stage. And then, similarly to our other programs, if the business is successful and established, there's a method for a return from that business to flow back into the university and OIP to fund future startups. And so I'd like to end just with some examples of Kyushu University's technologies. You can see a number of those companies here. And in particular, there's a few there that have got to the stage where they've actually listed on the stock market and become public companies. Probably the most well known is IQPS, or the Institute for Kyushu Pioneers of Space, which operates a satellite, radar satellite constellation to collect Earth observation data, which they then sell to both government and private customers. So yeah, thanks very much for listening. Happy to take any questions.
Thank you very much, Doctor, for your informative talk. So open to the floor for any question.
Thank you very much. Very interesting informative talk. I think I'm from the same Kyushu University side, so I'm sorry asking a question, but it's very interesting. Then you mentioned about the PARKS project to support these startup companies. Then how many candidates you support in the first step, and also how many you expect to become an actual startup company? Can you mention this?
So for there's a application period once per year for the PARKS program, and for step one, usually about 40 projects are selected from across all of the universities. But from Kyushu University has a pretty good record of being successful with the PARKS program. So of the 40, maybe just under 20 are usually from Kyushu University researchers. And then as you progress to the other steps, it becomes more competitive. So for step 2, -1, only 12 projects are selected each year. And then for step 2, -2, the final step, only 6 projects are eligible to be funded each year. In terms of how many become startups, it goes up and down every year. So far this year we've had, I think, 3 companies established. I will say that since the national universities were corporatized in Japan, there's been about 140 startups established by Kyushu University. I think we sort of rank in the top 10 in terms of the number of startups that we have established when compared to the other national universities. But like in the past, there have been years where there have been more than 10 startups established in a year. But I think typically it's 5 to 6 per year is sort of the average number.
Maybe another one question.
Hi, thank you for your presentation. I do apologize I came in a bit sort of halfway into your presentation. My name is Syed from UTM. I just want your opinion and your input as to the tough balancing act that we academicians, researchers, lecturers, we have to do in balancing between our sort of core business of teaching, research and so on, supervision, grants and stuff, and at the same time also trying to fulfill these commercialization and producing technologies for the societies, for the general good, and so on. So maybe you can give some insight into how Kyushu does that. Is it more like a carrots versus sticks approach, or are there incentives that you sort of empower the academicians there to pursue these initiatives? Thank you.
Yeah, we were just talking about this in the coffee break, actually. I think it's very much a carrots approach. I don't think there are any sticks, not that I've seen so far. But I think it comes down to what you as an individual researcher want to do. So at Kyushu University, there are some researchers that are very keen to get involved in establishing the startup and being actively involved in the business. But there are also a lot of researchers that don't want to be directly involved. They're happy for their research to be commercialized, but they don't want to have a direct role. They'd rather just be an advisor to the business, for example. So both options are possible. In either case, the most important thing for either researcher is surrounding yourself with the right team of people, right? Because starting a business, it takes a lot of time and a lot of effort, and you can't do it by yourself. You need a good team of people around you, and that's where we encourage the Kyushu University researchers to use the CXO bank to help them find other team members with the relevant business experience and business knowledge that can help them, particularly at the start, to help them set up the business and get it going and get the first customers. Because I think that's the hardest stage. So I think, finding the right team members, using the university as well. I know from my past experience, there are plenty of students that are also very interested in getting involved in entrepreneurship and starting businesses. So involving students in your project, and then working with the right investors too. So that's another thing that OIP does, is help the researchers find the investors that are a good fit, with them. Not just have the money, but are a good fit with them, personally, so they can work together in a proactive way to establish a startup. But at the end of the day, it comes down to the people or the team that you have around you.
Okay, thank you very much, Doctor, for your very long presentation and also very long explanation. Thank you very much. So please give a big applause to Dr. So next, I would like to introduce Associate Professor Toru Oga, who will give a talk entitled Theoretical Dialogue between Sheikh Hussein Alatas and Transparency International. Prof. Oga, please.
Thanks. Thanks for the introduction. So, terima kasih. Nama saya Toru Oga. Saya Profesor Madya di University Kyushu. Hello everyone, my name is Toru Oga, and I work in the faculty role in the Kyushu University, and I teach and research in international relations, and I look forward to presenting here today. So, today I focus on the corruption in the global south, and I propose the dialogue between the Transparency International, that this is the global indices, and the Malaysian intellectuals Syed, Hussein, Alatas, the theory of the colonial legacy, and KYUDAI. So this aim to connect the measurement and meaning to show how the political theory can inform what and how we measure, and how measurement they can define the theory and the process. Okay, I see this. So my background is international relations, and with a regional focus on the Southeast Asia. So across my work, I look at how the idea and discourse and institutions interact, especially under the corruption and the governance reform and the legacies of the colonial rule. And also, I use discourse analysis to understand how the policy narratives shaped and what we measure and how we act and react.
Okay, so we have the two perspectives here, the global one and the regional one. And the global one is the Transparency International. So they define the corruption as an abuse of and untrusted power of the private gain. And TA gives us the globally comparable tools, especially, I'll explain later, the CPI, GCD, and NIS, that shape public debate and policy agenda. And the strength of TA's approach is comparability and advocacy. It makes the corruption visible to the journalists, policymakers, and investors. Okay. Also, we have the local perspectives. That this is the Alatas one. So this is the corruption is a structural and historical, the rooted in colonial administration and elite continuities. So his concept of captive mind, the highlight, the intellectual dependency, the local elite, the importing external models with the limited adaptations. So it excels at explaining the why reform remains hollow and why corruption reproduces itself across the generations. So this tension is, however, is measurabilities, that they are the powerful ideas, but it is not necessarily the straightforward to the quantitative basis. Okay. So actually the question is like this: how can we use the Alatas structural insight be integrated with TI's indices to the better capture to the corruption in the global south? So it requires the hybrid framework, the retaining the TI's comparability and while embedded the colonial legacies and elite continuities and knowledge dependence. Okay. Okay. So the Alatas, that's Malaysian sociologist and a public intellectuals and professor and dean at the University of Malaya, and also his major work is the sociology of the corruption and density of Asia. So this is critique of Eurocentric assumptions, and he insists the meaningful reform requires intellectual autonomy and a public-minded scholars. So this this biographical details matters. He wrote the both analysts and participants in the governance. Okay, the core argument of Alatas is as follows. Firstly, the structural theory of the corruption. So colonial institutions and social hierarchies ended the incentives for rent-seeking. The second one is the captive mind. So the intellectual dependence sustains those structures by reproducing important models without the contextual. And the third one is the function and the harms. So while corruption may lubricate the bureaucracies in the short run, its long-term the social harms dominance. And finally, the role of the intellectuals and critically public-oriented intellectuals are essential to break those dependency and design context-sensitive reforms. Okay. Then the Transparency International, this is Berlin-based international NGO, founded in the 1993 with the 100 national chapters. It provides shared vocabulary and comparable numbers that mobilize the media attention and donor resources. So their indices, they have become de facto global standards that shaping how the government are evaluated. Okay, they have the three flagship tools, the CPI, GCD, and NIS. So the CPI is the aggregate expert and business service about public sector corruptions, and the GCD is the citizen service on the experience on the corruptions. And finally, the NIS is a country level assertion of this is the 13 institutional pillars such as judiciary and the audit, media, and the civil society, and etc. Okay, and CPI combines the 8 to 13 external data sources and standards to the 0 to 100 scales, And also, GCD asks the people whether they applied for the service and how corrupted they believe the various institutions. And finally, NIS rate institutional capacity, governance, and the role for each pillar. Okay. So actually there is some commonalities with TI and Alatas. The one is the corruption is a systematic, they not purely individual moral failure. And secondly, it impose heavy social costs. And thirdly, it requires the institutional reform, such as court, audit bodies, media, and the civil society. They must function autonomously. Yeah. However, there is some disagreement with TI and Alatas' idea. The first one is the perception versus structures, and the second one is it is like the quantification versus contextual understanding. So finally, the short-term sensitivity versus the long-term legacies. And so actually, we can propose the three-layer models. The layer one is colonial legacies and elite continuities, and the layer two is institutional pillars, and the layer three is the outcomes. For example, the structural corruptions, and we can use the GCD for the experience and CPI for the perceptions. Okay. So there are some previous literatures about the corruption and the colonial legacies. The first two is the classical studies. So this one shows the long democratic experience and legal tradition and study colonial history correlate with the lower corruption rate. And the second classical studies, this is the curvilinear relationship between political competition and corruption. So partial democracies, they often shows the highest corruption rate compared with the authoritarian regime and the high levels of democratic progress. So the third one is the more recent studies. The early Edward used the Afrobarometer data to show the indirect rule empowered the local chief and the communities, under those chiefs perceive highest corruption and show lower trust rate. And finally, the final studies, how the centralized administration, the divide and the rules and extractive economies evolve into the new patrimonial governance. So this is the sustaining the corruption. So what is the insight from the Alatas? So Alatas' added values is explaining the reform failures. Even with the new laws and the agencies, the reform can remain hollow when intellectual dependence normalize actually discourage those critics. But problem with the Alatas idea, the collective mind, is not directly measurable because without the critics may dismiss it is a purely normative. So the question is how we can use the normative theory and the normative perspectives into the models to quantitative data analysis. So this is four possible proxies. For example, institutional limitations, the legal origin continuity, and degree of constitutional or legal transportation. And the second one is the knowledge dependency, and the third one is law practice. And finally, the perceived autonomy, and we can use with them that this is the indicators of democratic countries. So we can use those indicators for the normative perspectives to analyze each country's the corruption levels. Okay, we have some case studies, but we skip this. Sorry. Okay, so there are two implications. The one is prioritize NIS pillars such as the judicial independence, supreme audit institutions, and media and civil society capacities. But they are channels through which legacies with edit into the outcome. And the second one is avoid perception-only analysis. So pair CPI with GCD experience and building structural indicators and these through historical context to interpret the gap and the plan credibility. Okay, and also we have the three recommendations. So firstly, triangulate measurement. They use CPI, GCD, and bring them together, and also the integrated local knowledge, the embedded in NIS assessment involve the local researcher and civil society to reduce those models to increasing the field. And finally, the trade corruption as the collective action program, the design incentives for cross-border coalitions, is not only the top-down enforcement. And finally, conclusion. So there is three takeaways. So firstly, the TA's indices are indispensable, but it is seen on the history and the structures. So secondly, the Alatas theory address the weakness explaining why the reform follow-ups under the colonial legacies and intellectual dependence. And so finally, we suggest hybrid frameworks, the legacies, institutions, outcome, the links theory to metrics, and in the better targeted policies for the global south. Okay, that's all of my presentation. Thank you.
Thank you for the presentation. So, for the Q&A session, is there any question?
Thank you for found your research very interesting. I just want to ask you, like, maybe I give you 3 or 2 questions. You can pick one you like. So after your research, if I ask you for one takeaway message from your research, what will it be? And another one is like after the bridging of the two systems, like what's your takeaway message? And also like, is there, in terms of the solution, do the two systems like they provide different solution or something? And the last one is like, in your research, is there any something like interesting you find during your research? So yeah, just carry questions. You can pick one you like. Thank you.
Okay, start with your question. So, as for the first question, so actually the big message of this research is, okay, we have global indicators for the corruption, but actually it is not only corruption, but also the human rights or something like that. We have the global standards, and normally we machinery applies to those global standards to individual countries, but at the same time, individual countries have a different context. So my suggestion is how we can. I think it is better to quantify the individual context of each country. So in this research, I try to bridge the gap that the quantitative, the global standard, and the qualitative, the contextual situation in individual countries.
So thank you very much, Prof, for your presentations. So please give a big applause to Professor. So next, I would like to invite Prof. Akimasa Yoshikawa will give the presentation with a title of Establishing a Global Magnetic Field Observation Network for Space Weather Research. The floor is yours.
So, hello everyone. My name is Akio Yoshikawa. I'm a professor in Faculty of Science, Kyushu University, where I'm conducting the research on space physics. So it's the third time for me to visit this Johor. I have been conducting the magnetic field observation with collaboration with Professor Zaini. He is also the president of Alumni associations. So today, I would like to report on Magdas project. It's the world's largest geometric observation network that we are working. So for over 40 years, Kyushu University group has been constructing global geomagnetic field observation network for space weather study. The name of this project is Magnus. So more than 150 observation points has been developed through the Magnus project. And now times so 70 observation points are in operation. So we are also operating the electric field observation by using multi-point FCW laser from polar to equatorial ionosphere at Kamchatka, Russia, Kyoto, Japan, Manila, Philippines, and Huancayo, Peru. So Kyushu University has been supporting this Magnus project through the establishment of 3 research centers, so CERN, X-ray, and iSpace. First, I would like to introduce a new center, iSpace. Kyushu University has re-established the International Research Center for Space and Planetary Environmental Science, iSpace. So as a successor to the Space Environmental Research Center, SAR, and the International Center for Space Weather Science and Education, ICSES. So the purpose of this new center further development of space environmental science and space weather science, and pioneering the space planetary environmental science by expanding its time and space axis. And so, this new center logo use the Chinese characters for universe to represent the universe. Which means this represents the people. So this is because we wanted to show that human networks have been as a core of our activity for over 40 years. So now taking another look at the Magnus observation points. So you can see that they are densely concentrated in the mid to low lateral regions. So they are densely concentrated in the this Southeast Asia. So typically, space weather phenomena such as the aurora occur at the high latitude regions. So, but in this magnetic field fluctuation also occur at this mid and low latitude regions. So which means this area serves as a primary battlefield for various phenomena occurring as a boundary between the space and atmospheric region. So we are focusing on efforts on illustrating the physical phenomena occurring there by using the ground magnetic field fluctuation data, satellite data, and also ground radar observation data. So solar wind and solar lights act as a dynamo for the Earth's magnetic sphere and atmospheric dynamics, generating global current system from outer space to ionospheres. So magnet systems capture the magnetic field disturbance generated by this process and contributes to the extension of space weather process by utilizing the data science. So this is an example of ionosphere currents reproduced by using the magnetic field data. So during the magnetic quiet periods, atmospheric movements on Earth and acts as a dynamo and generating the macroscopic current system. So therefore, the Magnus data can also be used to investigate the interaction between the solar magnetic activity and Earth's atmospheric activity. So this opens up a new field of research that examines the Earth's atmospheric variability from the perspective of the space weather. So on the other hand, so during magnetically disturbance days with active solar geometric activities, the ultimate effect of solar eruption phenomena on Earth are expressed in the form of the current system. Such a phenomena can cause the satellite malfunctions and health issues for astronauts, and GPS positioning data error and power transmission line failures. And so Magnus capture these phenomena through the magnetic field variations and contributing to the advancement in research for spatial with the environmental predictions. So this is animation of daily magnetic field variation snapshot data by using 1 year's worth of magnetic data. The ionosphere in the sunlit region has a strong electrical conductivity and causing such a vortex type currents to occur. This reveals the magnetic field variations associated with the atmospheric motion, enabling us to tackle a new field of the study called space meteorology. So this is a picture of the installation and maintenance of Magnus project. So it is strongly supported by local collaborators and many students and foreign partners participated in the field work. Over the past 40 years, so more than 10,000 people have been support these activities. Maintaining Magnus activity is a very important issue. Increasing the number of research partners around the world is one way to solve this issue and form the basis for capacity building activities. With that in mind, we will now introduce the educational activities we are engaged in on a daily basis. So other than the graduate student education. First, we focus to international activity. We have many observation points. So when we visit these observatories, we are actively contributing to the capacity building. As a result of this activity in Asian region, in 2012, the UN Magnus School was held in Indonesia. In addition, the data analysis workshop using the UNET system was held at Malaysia in 2018. And so not only in Asian region, but also in Africa, South America, and the European region, we constructed the contribute to capacity building. So over 200, over 200 page textbook was distributed for this Magnus school. And so these activity held every 2 years before the COVID-19. We also have a number of training for overseas researchers and students invited to Japan. For example, in March 2015, a symposium on space weather was held in Japan in collaboration with the United States nations. During this symposium, a capacity building through data analysis workshop was opened. In 2018, we invited the Malaysian Magnus officers to Japan for workshop to learn about the basis of the magnetohydrodynamics. And in addition, we invited the people from many overseas Magnus observation sites to Japan for training in the operation of the Alatas nanometers. And so now that so through the scholarship program, which is affiliated with the United Nations, we invited one or two master or doctoral students to the Kyushu University for about 3 months each year, and to focus on the writing their thesis, writing their papers. So this is project to build the integrated metadata base and analysis environment by institutes that have been ground-based observation data for atmosphere physics. UNIT. So UNIT has been have 3 action plans. Now in the third terms. First is the promotion of science activity in solar terrestrial physics. So second, international contribution and capacity building. And third, promotion of the scientific research on innovative areas. So in the cooperation with UNET, we accept the requests for both on-site online seminars. So if you would like to get some more information, please contact us. So from here, we will talk about domestic activities aimed to students and the public. We have presented our international activities in various meetings. However, we do not report about our domestic activities so much. So, considering the opportunity, many universities have open campus and events linked to the university opening ceremony. So through this activity, we are teaching children the joy of the research. And so in terms of the budget, we use various types of the grant programs. So it is very important for taxpayers, the citizens of our community, to learn about the research activities conducted at our universities. So there are many amateur research of astronomy around the world, and we try to use the field of space weather in the same way. So to achieve this, it is essential to engage in public relations activities that we can enjoy the parents and the children alike. So here in Malaysia, so there are many female researchers and graduate students, but it is not in the case of Japan. So Kyushu University has developed the program as providing intensive internship opportunities for talented high school girls to express the research. So we participate in this program every year to encourage the high school girls to pursue the research. And so we are amazing. So by their enthusiasm and rapid growth. So another way is alumni network. So many graduates of our lab have become high school teachers and technical college teachers. So engaging with the students is also important to get them interested in the teachers. In fact, there are several students who studied science under him joined our groups. So Magnus activity itself in Malaysia is supported on our line. So we mentioned it is important to get the parents to interest. And so this is the last slide. This activity is the academic side. So interdisciplinary science is also effective to accelerate the educational activities. We will introduce a Yosba Proba project. So this project is a student-led CubeSat development project. So So, undergraduate students at Kyushu University and the Kyushu Institute of Technology developed a small satellite. So, purpose of this collaboration is a human development between the different faculties. So, through the project, students from the Faculty of Science will study about the engineering. And the students from the Faculty of Engineering will get science knowledge. This project is supported by Japanese government next. Okay. So this is a summary of my presentation. That's all. Thank you very much.
Thank you very much for the nice presentation. So, is there any question from the floor? Maybe one short question from me. What is the main challenge when you collect the data from, especially for the data space?
There are many challenges, but so basically, by using very big data, the prediction of the space weather environment is a very, very important issue. So unlike usual thank you for the weather prediction.
Thank you, Prof. For the presentation. So we will come to the final presentation of the second session. So it is my pleasure to introduce Dr. Zatul Ifa Abdul Latif, who will deliver a presentation entitled Space Weather Impact in National Power Grid and Pipeline Systems in Malaysia.
Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Okay, sorry for the delay. Alright, so it is my pleasure to be here today to share with you an important topic on the topic that connects the space science and also with our national infrastructure. So we can see that the title of my sharing is Space Weather Impact on National Power Grid and Pipeline System in Malaysia. So allow me to introduce myself. My name is Zatul Ifa binti Abdul Latif. I am from the Faculty of Electrical Engineering from UiTM Johor branch, Pasir Gudang campus. So in this session, I will walk through with you about the something that we think about the space weather, something that we think that is quite far away, only relevant to the coast, but actually it has direct consequences for us here in Malaysia. So as you can see that I would like to emphasize more on the pipelines and also the national power grid in Malaysia. So let us begin with understanding on what is the space weather and then why Malaysia needs to pay attention on it. Right? So this is the agenda of my sharing today. So allow me to briefly outline about the flow of today's presentation. So first is introduction to the space weather. So I'm not sure whether all of you are familiar with this space weather or not. So we will briefly go through about what is space weather and what is the solar disturbances. And then second, we will examine on why does this space weather matter in Malaysia. And then next I will describe about the approach and framework of our study in which combine the satellite-derived solar wind data and also the geomagnetic observatories that we have in Malaysia. And then after that, there will be some sharing on finding case study about the things that we have conducted in Malaysia, and also we go to the future direction. Alright, so this is the research background on generally how the GIC is initiated. So why do I focus on the GIC? Because since I focus or emphasize on the pipeline, also national power grid, so the space weather manifestation that relevant to this is what we call it as the phenomenon of the GIC. Right, so let's go through the chronological order on how does this GIC is initiated. So we have starting from the solar event, and then it will cause the fluctuating current in ionosphere and magnetosphere. And also, due to this fluctuating currents, it will cause the variation of the magnetic field. And then, according to the Faraday's law, right? So we can see that the changing of the magnetic field will cause the induction of dioelectric field. And we know that what is the one that is responsible for driving the current to the technological equipment. So we have this dioelectric field. Since due to this dioelectric field, so it will eventually drive the GICs to the technological system, for example, national power grid and also pipelines in Malaysia. Alright? And then, so this is some animation about the detailed perspective on how this solar event gives impact specifically on the equatorial region. So when there is solar eruption, right? So all energetic plasma will be carried by the solar wind. And here I show is generated. And then we can see that the closest region that will receive the impact of the compression of the magnetic field is the equatorial region. And we know that our Malaysia, our country is located at the equatorial region. So that's why this is a matter why we need to focus on our national asset, which is pipeline and also the national power grid. And then after the compression happen, and then we have the magnetic reconnection. And then after that, we can see that the direct impact will be on the polar region. Okay? But then from this chronological picture, we can have the initial idea on how the GIC is initiated. But the thing that I would like to emphasize is on how actually the space weather, the solar activity itself, it can cause disturbances on the equatorial region. Okay? And then this is quite similar with the previous slide, but the thing that I would like to emphasize is on the ionosphere process that we have here. So I believe that every one of you know about the aurora. So actually, what is the thing that triggers aurora? So actually, the aurora is the scientific processes where the energy is deposited on the upper atmosphere, and then this drives ionospheric processes, including the well-known aurora that we see in high latitude region, right? So, but at the same time, so this ionospheric current is the one that causes rapid variation in the magnetic field, and then this variation causes the electric field, and then this electric field is the one that drives the GICs into the technological equipment. So, the same process that produces the beautiful aurora is the same process that creates trade to the country. So with this understanding of the change, so let us now look at why this is an issue of concern, especially for Malaysia. Alright? So we like to emphasize on the finding that we have on the from the geomagnetic storm that happened on the 10th to 11th May 2024. If you still remember, so there is a very severe geomagnetic storm that happened last year, and then this is the strongest since 2003, providing an opportunity to study GIC effect in Johor, Malaysia. Alright, so what is the effect of GIC itself actually? So we can see that the effect is more on the technological equipment, such as we have the power network, electrical equipment, pipeline, railways, telecommunication technology, oil and gas technology. But at the moment, we only focus on two assets, which is the national power grid and also pipelines in Malaysia. So why does it matter? Because the induced current is the one that causes the production of harmonics at the transformer, and then it also will cause relay tripping, voltage fluctuation, and so on. And this issue will eventually cause the power collapse. And what happened when we have the power collapse? If you still remember the event that happened in Quebec province, Canada in 2003, it caused the power collapse. At that time, Canada is not prepared with the mitigation strategies of this induced current. So it caused many losses, such as economic losses, and then all operations are halted and cannot be operated. Alright, so now let's go through why it matters to Malaysia. Why does this space weather matter to Malaysia? So first is national power grid, because we know that in Malaysia we have 275 kilovolt and also 500 kilovolt power network. And then the induced current will cause possible risks such as the overheating, harmonic blackout, and power collapse. And then also because of the oil and gas pipelines, and we have long pipelines in Malaysia. So for the pipeline, so the term of the induced current that we use is telluric current. So this telluric current is the one that can cause the accelerated corrosion of the pipeline. And then third is because Malaysia is located at the equatorial region. First assumption is equator is safe from DJI systems with the location itself is located far away from the polar region. But Malaysia is lies close to the EEJ zone, and then stronger daytime ionospheric conductivity at the equator, and then this cause higher induced current in ground-based infrastructure. And of course, why it matters? Because for national security and also economy. Because we know that when we have the power collapse, it will cause the economic loss to the industry, port, and etc. Right? Next, we go to the so geomagnetic field measurement. How does we investigate? What is the parameter that we use in order to perform to conduct the research? So we have the geomagnetic field measurement. So magnetic field magnetometer. So we can see here this is this magnetic instruments to measure the Earth's magnetic field, and then its direction. So this magnetometer is very sensitive instrument that records both the magnitude and the direction of the geomagnetic field. And then we can see that the system consists of the sensor, the amplifier, data logger, and GPS antenna. And then together they allows us to capture second by second changes in the Earth magnetic field. So in Malaysia, we are fortunate enough to be part of the MACDAS CPM and Global Magnetometer Network, which is coordinated by ISPAS, International Research Center for Space and Planetary Environmental Science, Kyushu University. And then I would like to take this opportunity to give a special appreciation to Professor Akimasa Yoshikawa for giving us the opportunity to be part of the MACDAS project. And then for your information, with this MACDAS project, with the geomagnetic field measurement, so it has produced, in Malaysia only, it has produced more than 20 postgraduate students. And also, there is up to 100 publications has been produced related to the magnetic field produced by the MACDAS, hosted by the ISPAS Kyushu University. Alright, and then the stations are located in Langkawi, Ranau Sabah, Johor, Terengganu, and Penang. So by having these monitoring stations across the country, so Malaysia is able to observe the weather station in real time and assess their potential impact on our infrastructure. Alright, so this slide highlights the installation of MACDAS 9 system in Johor, which has become one of our most important monitoring stations. And then, as you can see that, starting from the cabin and solar panel installation, and then we have the installation process of the data logger, and also the magnetometer itself, and then we have the chamber construction to locate the magnetometer sensor and also the amplifier. So this installation is carefully planned and ensure accurate and reliable data. And then the system was set up away from human activities, from potential, at least a few hundred meters from potential interference, so that the reading truly reflect the geomagnetic variation. Okay? So how does this measurements are used as the indicator of the GIC? So how does this geomagnetic field can be used as indicator of the GIC? So this is from this is the three-dimensional vector of the magnetic field component, and then we can see that the parameter used is HDZ and XYZ components, and then we use the time derivative of geomagnetic field, DBDT, used for the indicator for DGIT activity. So this is the equation of DBDT. So the DBDT itself representing the rate of change of the magnetic field. So the H parameter here is indicating the resolution of the GIC, the geomagnetic field data. And then the length is the H is actually the sampling interval. So in this case, the length interval used is 1 minute. So from the previous research, DBDT beyond the 30 nanotesla per minute serves an indication of the presence of the GIC. Alright? Okay, so next is I would like to emphasize on the why we need along besides the geomagnetic field itself. So the parameter that we need to consider is also the conductivity, because different source, because it's related to the underground equipment. So different source, it has different conductivity. Of course, so that's why we need to consider the value of the conductivity in order to get the value of the geoelectric field. And then, at the same time, in order for us to model the GIC's current, we also need to consider the network topology and the resistance of the national power grid. So that's why the GIC's value is unique every country, because every country has different topology of the power grid. Okay, so next is the measurement of the GIC. So normally, in addition to modeling the GIC, it is very important to directly measure them within the power grid. So this diagram shows how it is done. So at the neutral point of the transformer is where the transformer is grounded to the earth. So a GIC can flow into or out of the system. So to monitor this, we use the current clamp installed at the neutral point. So this current clamp will be connected to data logger, and in this case, we use this device. And then by combining this measurement, direct measurement with geomagnetic field observation, so we can validate the model and also provide the real-time monitoring to assess the risk of the national grid. Okay, so this part of measurement is now ongoing research, and then we have collaborated with the DMV research for this investigation of the GIC. And then this is the finding and case study related to the previous or last year geomagnetic storm that happened between 10 to 13 May 2024. So I would like to highlight on the DBDT that we have obtained from the Johor Observatory. Right, so the highest DHDT was recorded at 63.4 nanotesla per minute on 11th May. So this DHDT is exceeded in 10 events during the storm, indicating the potential GIC risk. So this is the largest, the highest DBDT that we have obtained from the past few years. So most of the DBDT events occurred during the main phase of the geomagnetic storm. And then this case study focused on the severe storm from 10 to 13 May 2024. Right, so and then we can see that this is the what we call it. This is the phase of the geomagnetic storm. So we have the initial main phase and also the recovery phase. And then from there we can see that about 10 events that surpass the values of 30 nanotesla per minute. Alright, so next I would like to highlight on the measurements of GIC at pipelines in Malaysia. So for the pipelines investigation, so our concern is on the catalytic protection. So here I would like to show to you, this is the data logger installation and pipeline test pole. So where we have the voltage data logger and we have the current data logger, and then the voltage data logger is the one that measures the PSP, pipe to soil voltage potential. And then we know that in order to, so this is the pictures of the data logger installation, and then this is the result. So we can see that normal catalytic protection is at 100 and 1150 millivolt. But sometimes, due to the ghost reason, previously we calculated ghost reason, so the catalytic protection exceeded about 2500 millivolt, and we do not know what is the cause of it. So because when we have the over catalytic protection, so it will accelerate the corrosion of the pipeline. So that's why we have performed some investigation. We put the data logger, we want to actually measure. So what happened? So we can see that at the point here, right? So we can see that there is one event. Notice how the sharp spike of the geometric field coincide with the surge in the pipeline potential. So this provides strong observational evidence that the space where the activities translate into the measurable disruptive effect on pipelines here in Malaysia. So we can see that, so here there is one spike here at the magnetic field, and then here at the pipeline PSP, pipe to solve voltage potential, there is also surge here coincide. So this kind of result is very important because it demonstrates on the anomalies of pipeline, the anomalies in the pipeline investigation. Alright, so but in fact we can link it to the space weather phenomenon. So that's why the space weather phenomenon is the space weather investigation related to the industry is very important. So this is the further future direction. I think that's all for today. Thank you for your attention. Alright, thank you.
Thank you very much for the presentation. Maybe one question from the floor. Any question? Okay, so if there is no other questions, so thank you very much, Doctor, for the presentation. So now we are coming to the end of this symposium. So in our closing session, I would like to invite Associate Professor Dr. Halim, the representative of Malaysia Kyushu University Alumni Association, KYUDAI, to deliver the closing remarks. Please welcome Dr.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. It is a great honor as a Vice President of Kyushu University Alumni Association, or KYUDAI, to deliver the closing remark for today's KYUDAI Now Forum 2025. First of all, I would like to sincerely thank to Kyushu University Institute for Asian and Ocean Studies, our distinguished professors and colleagues from Kyushu University and Malaysian partners, especially University Technology Malaysia, for making this event possible. Today's program has been very meaningful. We heard many valuable presentations on environment, energy, society, science, and innovation. These topics are not only important for research, but also for our daily life, our industries, and for the future generation. The discussion today has shown us that by working together across countries, disciplines, and cultures, we can create solutions that have real impact. For us in KYUDAI, this is exactly what they aim to do. Our mission is simple. First, to bring together alumni of Kyushu University in Malaysia, to share our experience and knowledge with the wider communities, and to build stronger friendship and cooperation between Malaysia and Japan. Being an alumnus is not only about remembering our time at Kyushu University, but also giving back. We want to inspire the young generation, contribute to society, and continue building bridges of collaboration between our two countries. On behalf of KYUDAI, I would like to thank everyone here today, our speakers, participants, and organizers, for your time, energy, and support. This event has been successful because of your commitment. As we close, let us carry forward the spirit of collaboration and friendship that we felt today. Let us continue to share knowledge, strengthen networks, and work together for a better and more suitable future. Thank you very much. Arigatou gozaimasu. Terima kasih.
Thank you very much, Prof. Halim, for the closing ceremony, the closing remarks. So So now I would like to invite Prof. Shimizu Suji, the Vice President of Kyushu University, to deliver the closing remarks. The stage is yours.
Okay, thank you everybody for being with us until the very end of this today's forum. As now you understand that this symposium is the first time to combine both Campus Asia and KYUDAI Now Forum. So for me, this is the first time to join the Campus Asia, and I'm so much impressed and surprised to see the very good program for the students here. You know, there should be students from Korea, China, Japan, Kyushu University, and here in Malaysia. And I saw the program that shows a meticulous plan, matching the students with the teachers and lectures and the discussion time. You know, I so much, marvelous program. So I think it's a very good chance and opportunity for all the students here to be involved in this Campus Asia. And on the other hand, the KYUDAI Now originally has the idea that we invite variety of professors from our university to deliver the different field of presentation. So for Campus Asia, I believe that many of your students are from engineering faculties. But for KYUDAI Now, we invite, for example, from Faculty of Law, like today, and the Faculty of Science, and not here today, but we have invited from the Faculty of Design, Faculty of Medicine, Dental, Pharmacology, Human Sciences, all variety of field. The original concept of the KYUDAI Now is to introduce the state-of-art lectures so that we can share the variety of ideas to build up new ideas. So I think today this is a very good chance to combine these two programs together so that all the people here can share the different kind of concept and the disciplines. So for the student here in the engineering faculty and Campus Asia, I think it is very, very good, very important to learn deeply and polish your specialty into your own field. But on the other hand, I think it is very important to widen your knowledge and experience and something like that. So for even for my own experience, I have a medical background. I myself is a surgeon, so I have worked for a long time only in medical field. But now I moved to the main campus and looking at all schools as a vice president for international affairs, and I found many interesting fields, including agriculture or design or many things. And I'm happy to know the new field. They are a lot of fun. So anyway, so this is a very good occasion today, and I very enjoyed today's presentation, and I do hope that we have another chance to combine the Campus Asia and the KYUDAI Now in the near future. So at the end, I will not thank you again because all the people say thank you, thank you, thank you. So just a thank you for everybody here again. And let's move to the hotel for the party so that we can have more time to know each other better and have more chat between us. Thank you very much.
Thank you very much for the speech. Ladies and gentlemen, thank you for your kind attention. We will now proceed to KYUDAI Spring Resort for the dinner reception. Shuttle bus have been arranged by Unused Technology Malaysia for your convenience. So for those who are driving, please proceed directly to KYUDAI Spring Resort and follow the direction provided by the committee. So again, we truly appreciate your participation throughout this today's program, and we look forward to sharing